Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Welcome to Schweitzer Drive. I'm Nic Seeley, Senior Vice President of Engineering Services at SEL. I'm guest hosting today for part 2 of our Ask Dave series. We flipped the script and are kicking off season 7 of the podcast by putting Schweitzer Drive host Dave Whitehead back into the hot seat to answer your questions. So these are questions that we have gotten from LinkedIn and some various other places. Not all SEL employees. Actually, most of them were not SEL employees. So this is really fun to see what our listeners are interested in and want to hear from you about Dave. So Dave, welcome to the show for round 2. Are you ready?
I am so excited.
All right.
Does that sound like I am? Because I really am, right? This is kind of fun. I get to answer the questions that the people come up with and not necessarily ask all the questions.
I'm ready. We got some really good questions. The first one that I wanted to ask is from Dylan, and I like this one because it's not just straight technology, but the question is, does grid reliability depend more on technology or the psychology of the people running it?
It's an interesting question, and the word that stood out to me is the psychology. Is it the psychology or the philosophy? Right? Do we want fully redundant, triple redundant systems? That would be the philosophy of how a utility, I think, would want to go about protecting a transmission line, or perhaps they do distribution protections or something. And then we can compare and contrast what's more importantly, the philosophy versus the technology, if that's okay with you. If I'm reframing it.
No, I think that's good. And the way, when I looked at psychology, I was thinking there are operators that have to make decisions, and those decisions are sometimes based on intuitions or procedure and things like that. So,
I think maybe there's a third part to this question.
But I like the philosophy. Like, you and I are no strangers to having kind of philosophical conversations about things. So I'm interested to see what you think about the philosophy.
So here's the easy part. I think I'm going to start off with the dependability of the power system really does, at its base, require some kind of technology, right? We can't have 765 kV lines unless we have really big breakers, and the technology that goes on with them, all the way down to relays or whatever that goes into our power system. I'm going to say we have some cool technology like our traveling wave, which is a little bit different than other people, allow us to detect a fault that, we can detect a fault in a millisecond or so, right? So that's a technology, perhaps a differentiator, that allows us to be a little bit faster. But then it comes down to the philosophy of how am I going to use that technology? We have a lot of customers that really appreciate the speed of it, right? They're taking the trip times from, say, 4 cycles, 3 cycles down to 1.5 cycle or so, which is a big improvement. It's less stress on equipment. If we think about from stability standpoint, certainly we want to remove a fault as quickly as we can. But now we get into the philosophy of how I go about protecting that power system. And one thing I've heard from some of the system planners is it's, when I have to do a stability study and I'm worried about that, it's really going to be an N-2 condition. And then really what's going to be the dominating factor is the assuming that I have like a 2 or 3 cycle breaker and that is perhaps, not working like it should. So there's this philosophy of how and when do I trust my technology to protect the power system, given some level of technology.
Yeah, it makes me think too back, when we learned about the elements of protection. You've got like speed, selectivity, sensitivity, and some of these are in tension with each other. So you want to be sensitive, right? But you also want to be selective, or speed and all of that. So that then comes down to a philosophical discussion of like, do you want to prioritize speed at the risk of one of these other things?
And so if we get back to it, I'm going to probably make an argument is how reliable or dependable is your system really comes down to the philosophies of which you go about deploying the technology that perhaps your neighboring utilities use too. So I really think that probably the reliability or the dependability comes down to the philosophy more so than perhaps the technology, given that everybody should be using blue boxes, right? So it's it's really your philosophy of how you want to go implement these things.
Said another way, is that the technology, the philosophy drives the technology?
I'm gonna say, and I'm certainly biased because we're doing Schweitzer Drive, right? But our technology allows different philosophies to be applied on power systems.
Do you want to try to touch on the psychology one?
Oh man, I hadn't thought about it. Maybe I'm just too black and white. But you're right? There's operators that are looking these huge displays trying to operate and control power systems. I haven't thought too much about the pressure that goes with those kind of the psychology of operating those power systems. In fact, I'd like to, if I could, and I was an operator, I don't want to push as many of those decisions to an automated system as I could.
Yeah, I don't know. It makes me think of you've got the operator, and I am largely unaware of exactly how they go about that. But I think they've got, in some cases, very, very specific procedures that they follow. So I don't know that that's as much about psychology as just like following procedures.
Well, okay, and it's nice if you've got a procedure because it's well thought out and stuff like that. But I can only imagine what happens like during a windstorm where we had 100-mile-an-hour winds here the other day, right? And you're watching this big board and things are just popping off and dropping off. Or perhaps the folks at San Diego in their operations center, right, when they had their big blackout, and it's like this is unplanned, unanticipated. There was no procedure, right? All of a sudden you start losing load and all this, but a lot of things look normal, right? So how do you manage systems like that?
Well, that makes me think, I mean, you sometimes quote Mike Tyson, right?
Yeah, exactly. We all do.
Yeah, everybody's got a plan until they get punched in the mouth.
Yeah,
right?
exactly.
So, yeah.
Okay.
All right. Another question from Samantha.
Mm-hmm.
How do you see small modular reactors or SMRs impacting? I'll modify this a little bit, but impacting the grid, and then also impacting power system protection control technology.
Okay, you're going to modify that because that's exactly the way that I read that sentence.
Yeah, I think that was. I think my modification was generalizing it to impacting power systems, and then more specifically, in the question was power control and protection technology.
So I think there is a lot of promise for these SMRs. I wish we could get them done sooner. And the way I think of these SMRs, right, they could be like 300 megawatt units. Maybe they'd be a little bit bigger, right? And you can scale these things. Some of the ones I've seen, the nice thing is they spin a traditional rotating mass, kind of like just smaller versions of, an AP1000, right? Mm-hmm. That is this huge nuclear generator, but that has a traditional, let's call it a mechanical system setups, right? So it gives us nice things like inertia, mm-hmm. right? And dispatchability that we also like from these systems. So I think there would be a huge benefit to the electric grid if we could have SMRs deployed throughout the power system. Of course, it's going to change the way things look a little bit as opposed to having a big centralized generation station supplying energy to lots of different places in a geography. Rather, these will be little generators all over the place. So it becomes a big buswork. So I think we're able to handle those things. You guys in engineering services build these, microgrids. Let's call them macro grids now if we were having SMRs over there. So this is, I don't think it from a technology standpoint or an integration standpoint be much of a challenge for us. So I see a lot of upside to the SMRs. Of course, the challenge is that the technology right now is not, mass produced in service. I think I've heard of one SMR that's actually being built right now. There's some studies going on around in this part of the country that they're talking about. But I see a lot of opportunity for SMR if the technology can meet the promises that it's talking about.
Yeah, I like you brought up the microgrid. So in terms of like how it would potentially impact the control and automation of it, it seems like you might have more the capability of having power grids that can separate and connect more easily, just because you've got a lot more distributed resource.
I'd agree with you 100%, but I from a technology challenge or standpoint, I really don't see a big problem. Right? We've done things.
Yeah.
You guys do stuff like that, right? It's like getting a petrochemical plant on and offline, right? You guys island and separate and
yeah. Okay, here's one. What's from Stephen? What is the most exciting innovation in electric power today?
The most exciting innovation in electric power today. Is it, or now frame the question for me, is it technology in production or technology that's being worked on? Or let me call it the innovation, right?
Yeah.
Is it a released innovation?
I like both of them.
Okay, well, let's go. Let's start with the future promise of innovation. And I'm going to say fusion is really interesting, right? Fusion has always been 10 years away. Always 10 years away. But there's some interesting work. Helion, right, in the western part of this state is got some fusion reactor ambitions over there. And I am, if we could perfect that at some point, that would be some really, really cool innovation happening. When it comes to innovations that are shipping right now, I talked a little bit about the traveling wave. It's really an interesting way to protect power systems. When I was going to college, I'd come home, after being at work for a while and said, "Hey, Mom, all those classes I took, except for, signals and systems and the traveling wave, I've used all those classes, but that one." And now I can say we've actually, I think every class I took in college, I've used in one of our products or not. So that's some cool technology. You guys are working on some interesting stuff when it comes to the cybersecurity. It's like, what do we typically say right now? It's what is inherently cyber secure, right? When we talk about innovations and how to do that, right? We look at first principles and what is the root of that? Because right now, maybe you'll disagree with me, maybe you'll agree with me, is when it comes to cybersecurity right now, it's very important for control systems. Right. And the systems we operate in on the OT side are, if something goes wrong, people can die, equipment can be damaged. Right. So it's really, really important to get it right. Now we have some, our OT systems and IT systems are a little bit different too. Right. So we can lock things down a little bit more than perhaps we do with an IT system. But the security things that we're putting in place right now, whether it's OT or IT, I could probably make an argument it's always one more Band-Aid. It's like, and its roots come from the communication systems or how we set everything up. It was more for convenience. Isn't this cool? Can't we get it up and running? And then you go, oh, but there's a vulnerability, right? So we're trying to put the genie back in the bottle. And some of the work that you guys are doing is like, if we could reset and do it right the first time, right, from perhaps a cybersecurity perspective, what would we do different, right? So when we talk about how might we innovate in this cyberspace, I get kind of excited about that area of work.
Yeah, that's something I could talk about for days. But
and Kate said we only have an hour, so
no, I definitely agree with you though. There is there's a lot of good things in cybersecurity. So the most empirical of cybersecurity is cryptography, right?
Yeah.
I mean, that's all mathematically based, but a lot of the other cybersecurity stuff, in my opinion, is done because it just seems like it's a good thing to do.
Yeah.
But there's really not a whole lot of empirical evidence that it is. And we can see that in things like all of the different guidance we've been given on passwords throughout the years, right? It's like all these things. So
you talked about cryptography, and we're talking about innovations and whatnot. Now let me turn the question back on you, right? And I don't know what the right time frame for this, but quantum is always a year away or 2 years away. What's the impact of all this cybersecurity and crypto, right? If quantum comes to fruition.
Yeah, and then you get into whether or not it's symmetric or asymmetric crypto, and like one of the things that I've read about specifically about quantum and the technologies there is we don't actually know what it's going to bring. Like we believe that asymmetric crypto will be broken. I think most people are pretty convinced of that. But the symmetric side of things, and if you go back to like Shannon's theory of like the one-time pad and things like that, will that be, and will quantum be any sort of quantum technology be able to crack that? Like some people say no. Some people say, well, we just don't know because we don't know what quantum's capable of. So, no, yeah, that's really interesting. So you mentioned traveling wave, and I think we've talked about traveling wave before, but the interesting thing for me about traveling wave with what you said is you finally got, I think what you were getting at is you finally got to use electromagnetics in signal processing. So
characteristic impedances. And I do that when I design circuit boards, but never on that. I thought I'd be using for the power system.
Right. Yeah. So that was, I had a similar experience too. So I think we got both of them, like the future stuff with fusion and present stuff. All right. So here's one is kind of maybe a booyah, but Riley is asking, how is SEL planning to grow globally in light of the uncertainty that we have with tariffs that they've created in the last year? Has any consideration been made to establishing device manufacturing facilities outside of the U.S.?
That's a great question. One I have to grapple with just about every day. Just as a point of interest, if you will, to date, we probably in 2025 will pay about $35-40 million in tariffs. So that's while we prefer to source all of our components locally, close to our factories. We do buy parts around the world, and lots of these parts lots of these countries have tariffs placed on them. So that's what we're seeing. And then another point is if all of the tariffs that are enacted or have been considered to be enacted, I'll say it that way. If all of those actually enacted or could be enacted, cost us about $150 million in let's call it a tariff tax. Mm-hmm. So yeah, those tariffs, get my attention. We had the opportunity to go talk to the U.S. trade representative earlier in the year, and what he was trying to find out was what are the impacts going to be to a company like us. And now it was SEL. There was a person from I'm drawing a blank, but anyway, they build oat bars. But so we had a diverse bunch of folks talking to the trade representative, and it became my turn. And I said, hey, we're in the process of figuring out where we want to build our next electronics factory. We have a couple options. We love building in the U.S., but here's the thought process that we were going through is what if instead of building our next electronics factory in the U.S., we decided to build it outside the U.S. Pick Mexico as an example. Use that facility then to supply all our international folks, so we don't have to worry about tariffs, parts coming in or going out. We're perhaps getting retaliatory tariffs when we ship a product outside the U.S. And I think that at the time anyway, that shocked the U.S. trade representative. He goes, "Oh crap! I didn't figure you guys might want to do that."
Did you take a picture of his face as you?
He was just looking at there were 3 aides next to him, and they were just scribbling furiously about that. Now, we actually did just last month decide where we're going to build that factory, and it's going to be near our Pullman facility, but over in Moscow, Idaho. So we evaluated those options and decided still in the best interest for a number of reasons to build the factory in the U.S. That doesn't mean we won't build something in the future. We're going to do some experimentation to see what it might be like, but we don't have any plans right now to build a full up factory outside the U.S. And you know what? Here's the thing. There'll be a new administration with different priorities, and we'll see where tariffs go. It's tough these days with the political environment in the U.S. It just seems to seesaw from one spectrum to another, and it makes it tough to run a business when you don't have a lot of certainty what's going to happen in 6 years, because we're building a factory that's going to last for 30 years. So fun times.
Yeah. I'm glad you have your job and I don't have your job. Okay, here's another one that I really liked. So Jessica asked, what's been an unexpected highlight from season 6? Maybe a connection made or a story shared, and I'll add, like, did you learn something that maybe changed your mind about maybe an opinion that you had or held?
Ooh, that's a good question. It's like, which is your favorite kid, right? It's like, all of my kids are my favorite. I love
them all equally.
Exactly.
Yes.
Is that the right answer?
Yeah.
Here's it. We had a series on nuclear that I thought was really fascinating, right? We talked about, folks that were doing SMRs. We talked to the Westinghouse AP1000 folks, and I found those to be really, really fascinating. And it's more of how these things will or do fit into the power system, right? And the impact, not necessarily it's like, it's a 1.2 megawatt or gigawatt, system, or a 300 megawatt system, right? It's the reliability, the stability, the ability to deploy these things, talking to the AP1000s, it's like, these things don't need to be huge cost overruns if we were allowed to build more than one every 20 years, right? When you start thinking about the economics behind how you do this, the more I can build, the better off we're going to be. And then you start going down the roads. Okay, what are all the impediments to building more? It's like nobody likes nuclear in their backyard. And then you ask yourself this question, well, in the U.S., how many people have died from a nuclear accident? And the answer is 0, right? And then I go down this crazy path. It's like the Navy has, probably certainly over 100, probably closer to 200 little tiny reactors, let's call them SMRs, if you will, floating around the sea all over the world, being operated by 22-year-old kids, right? Yeah. So it's a pretty safe technology, and I'm always a little bit dumbfounded why we don't go a little bit faster with these systems, especially since they'll be operating for 80 years or so.
Yeah. Okay, here's another one. I'm interested in this one then too. Camden and Jace ask, who's your dream podcast guest? If you could invite any scientist, engineer, or leader from now or history, who would it be?
Who would it be? There are so many. Everybody would probably say Edison, right? It's just like, man, what makes you tick, right? That would be perhaps interesting one. I'd really like to meet would be Rickover. We're talking about
that's a good one. Yeah.
My dad had the opportunity to meet him one time,
really?
right? And he's an interesting guy.
Yeah.
That'd be another fun one to see what makes you tick.
Interesting guy. Was that? That's artfully phrased.
Well, it's this is rated for families. So, and here's the other one. And perhaps not at the time when he was the president, but it'd be fun to have a beer or a cup of coffee, I think, with Reagan. I have such respect for, the guy was so smart, in my opinion, and his sense of humor was so funny. I can't imagine.
Guy,
he was. You just had to love that guy, right? So I would really like to have a beer or a cup of coffee with President Reagan.
All right. So we got another question from Jace, and he's talking about virtualization. He's saying virtualization is gaining traction. Things like SEL's Blue Frame and some other products, digital substations are out there. What excites you the most about this trend? Will virtualization be the most transformative technology of the next decade, or will things like generation-side advances like battery storage or nuclear take the lead? And as a second question, how should utilities design systems today to stay adaptable?
I think that's a great question. There is a lot of interest in this idea of virtualization or centralized protection and control. And I think we need to be really careful too, because when I say virtualization, I may have some concept of what it is that may not match necessarily with what Nick has, or when we talk about centralized protection, really, really what is it? So I'm going to frame it in this sense that virtualization or centralized protection it's abstracting where let's call it the protection algorithm has to run. Back in the day when Ed created the 21 relay, there was such a tight coupling between the firmware and the hardware, and there had to be. It was a 2 megahertz processor. He only had a little bit of memory. He couldn't actually use a multiply function. Right. He had to do left shifts and adds and do some clever math, because there wasn't enough time to throw a lot of horsepower at these devices are going to get sent out into a substation. These days, with the advancement of technology and things we're able to do, we're actually able to more and more divorce the hardware from the software. So I can have a common hardware platform that I can put in different protection algorithms. So that's what I'm going to call the virtualization or the centralized protection idea. And I do see a lot of benefit from it. Then there's going to be challenges too. But, if I had to articulate some of them, it is, and the benefits the customers are seeing, it is one box I have to manage inside a substation. I think there's a lot of merit to that. Right now, if there's a firmware bug or an upgrade that needs to happen, they need to touch perhaps, 15, 20 relays inside a substation, depending on how big the substation is. The promise, the benefit, if you will, of this virtualized one is that if I have to do an upgrade, I'm only going to touch one piece of equipment. So when you look at OMM costs and other things, there's a huge amount of savings. Maybe from a cybersecurity standpoint, I only have to protect one device, not a whole bunch of devices in a substation.
Yeah, it's interesting, right? Because you're protecting one device, but you're protecting millions and millions of lines of code on one device, right? So it's kind of like that. You shrink or make something a little bit more simple by having fewer devices, but potentially the complexity goes up because you just have lots more lines of code.
You do, right? And a word that drives Ed crazy, and I totally appreciate it, and I agree, is this idea of simplexity, right? So am I by putting everything in one box, the customer from the outside, it looks very, very simple, but on the inside, man, it is just thousands and thousands of lines of code or different processes that need to interact with each other, right? So the complexity is inside is a lot, but perhaps from the outside, the simplicity is apparent there. But we're going to head there. There's going to be centralized protection to call one form or another. How fast it rolls out, I think, depends on the utility and their appetite for doing something different and new. And recognizing when we do something different and new, there are going to be bumps, there's going to be challenges, and we're going to learn things all along the way. Ed reminds me, ever since I started here, right, that a power system is not a laboratory, right? You don't get to experiment with it. You better have your ducks in a row before you start getting things out there. But we've got a lot of smart people thinking and looking at this. It's I do want to be a little bit cautious when we roll stuff out to make sure we've got a great, solid solution, because the other thing is, you start screwing up, you get a black eye on it, and nobody's going to want to touch that technology. So I see a lot of promise in it. Just to make sure we do our, first principles, dotting I's, crossing T's approach to coming up with a solid system that really is solving customers, big problems. But I think with a centralized protection, you could, literally ship from stock a substation, and because I'm virtualizing how many relays I need or how many protection elements I need, I don't care if that ship from stock box is ending up at a substation with 10 feeders or 20 feeders. It's just not going to matter. I just need to hook up the measurement devices that are out in the substation yard next to a breaker or transformer or whatever. So there's I think a lot of promise with this.
Yeah, hardware independence, right?
Yeah.
And okay, so let me ask you. So I think how the question posited is like, will virtualization be the most transformative technology, or will some other thing? So if you had to bet, do you think virtualization or like CPC will come first, or do you think things like nuclear or battery storage will become, which will happen sooner, which will be adopted sooner? What do you think?
We sort of have batteries out there right now. And I think there's going to be a place for them. The thing I always get a little bit, I don't know, not as excited about batteries. They're usually rated in hours, 4 hours typically. I'm going to get, 4 megawatts for 4 hours. Well, what happens on the 5th hour, right? We had this big windstorm. My house was out of power for 8 hours.
Okay.
Right. And so it's like, I know it's not going to be able to carry me through a windstorm. Maybe the argument for batteries is really just for peak shaving, right? Yeah. It's that one day duck thing, right? Yeah. Where I got during the middle of the day and nobody's using a lot of electricity, at least not in my house. It's going to pump up. So maybe there is. Batteries just, they're nice. It's like, I don't know, vegetables or something like that. It's like, I got to eat. Well, we had Friday lunch. I didn't eat any vegetables today either, right? It's like, maybe they're not even as good as vegetables.
I like vegetables.
I know you do. So batteries, it's like, I don't know. They're going to be there. They're okay. Nuclear, I really get excited about nuclear. It could be very transformative, but it's going to take a while for it to happen, right? So I think if we're talking near term, where we would probably have a bigger impact out of those three things you talked about, it's going to be that centralized protection. Yeah. Now, I don't think it's going to take off like a rocket either. I think, again, we are a conservative industry, right? So it's going to take some time. But I think we're getting to a point where we can deploy the technologies, or we will be, not in the not too future, where we can build a reliable system. So I think that's the shorter term out of those three technologies we're talking about that we'll see more often out at a substation.
Okay, so we got a question from Mackenzie, and that is, what advice would you share with a high school student considering a career in engineering?
Well, we've won half the battle right there because they're considering a career in engineering, right? Right now, I think our biggest challenge is how do we convince a kid to be in engineering? This person's already considering it, so yay.
All right, so you have to convince somebody to be an engineer or be, I don't know, a doctor or a lawyer, or like how do you convince them?
What's my spiel?
Yeah,
I think. Well, first, if somebody has a desire to be one of those, I'm probably not going to talk. Those are great professions. But being an engineer,
that's very diplomatic of you.
I know, isn't that weird? I'm a different guy when I'm behind the microphone, aren't I? The thing about the engineer, and you can see, you have a son. I bet he's going to want to be an engineer. They just have this what it was that the knack, right? Where they can take apart stuff. They want to figure out how things go together. I was telling folks at Friday lunch today. I thought forever I was going to be a lawyer just because I love arguing, and you can be an engineer and still argue. I've come to find out. But what the spark went off in my mind when I took a physics class, and I really just fell in love with the idea of taking that math and science and building something with it, solving a problem, pointing to, the most satisfaction I get when we come back to this, I'll walk into a substation and see a blue box that I worked on, right, being installed. Somebody paid money for this thing to protect a power line or something like that. I mean, there is so much satisfaction and getting there, going through, and engineering it can be there's some tough subjects that you have to go through and master right before you can build a product or do some other engineering function. So it's not the easiest of all majors, but man, again, walking into a substation or a project that ES has worked on and seeing some customer wanting to pay for it because it's going to make their job or whatever their process is easier. It's so gratifying.
Yeah. I was earlier this year. I was in Saudi Arabia where I did a project 15 years ago, and it was still running. Still running.
Isn't that
still
amazing?
running.
That's
awesome.
Feels so good.
Yep.
Right.
Yeah. I'll end on this one. In this one, speaking of charming, I think Gordon did a good job because I would not have been so articulate in this. He asked, what does a typical day or week in the life of Dave look like? And I say that because how that would have come out of my mouth would have been something along the lines of like, so what is it you say you would actually do here, Dave?
Can I tell a funny story?
Yeah, please.
Okay, before I answer the question, Dr. Schweitzer, Ed and I were coming back from the East Coast. We'd been out there Monday, and then we're coming back on a Friday. And we just, when you're doing these trips, you're familiar with traveling. It's just, you're having breakfast with somebody at 7:00, and you're having dinner with somebody that doesn't end till 10 or 11 or something like that, and you're busy the whole time. So we've been running around for days and days and days, and we're flying back after probably a dinner, late lunch or something. And I'm thinking in my head, it's like, well, I get back, I got to work on this project, I got to do this and whatnot. And Ed's sitting next to me, he's reading a book, and I'm kind of thinking in my head, and all of a sudden I start talking, and I go, Ed, I know what an engineer does, but what do you do all day, kind of thing, right? and I was,
what is it you do here, founder of our company?
Exactly, right? And my thing is, well, I know what an engineer, I spec, design, build, test kind of stuff, right? Now, what I wanted to do was like, what occupies your time? What decisions should you be making? But it really did come. I was like, what the hell do you do all day, right? I'm lucky I still have a job here. But getting back to me, what is a typical week or something like that? I'll use today. It's a pretty typical day. I get up in the morning a lot earlier than I used to when I was developing products. When I was developing products, I'd get into work about 8, work on my projects, go home, have dinner with my kids, put them to bed, and then I'd come back and I'd sling code or test hardware or whatever it is I was working on. These days, since, we're, Nick, I know you get in even before I do, right? We're a multinational company, so we got a lot going on around the world at any point in time. So I get up about 5 o'clock, I check some emails, turn on the news, feed my dogs, work out probably for a while, get into work, I don't know, between 7:30, and that's usually quiet time. People don't show up till about 8, so that's another time to get.
It's nice.
It is. It is kind of like your time, right? I can get caught up on email or set agendas, or maybe if I have to write something down like papers or whatnot, and then the day starts really at 8 o'clock in earnest. And I come home, my kids ask me what do I do, and I say, I was in meetings all day, right? And the meetings are really, really varied. Today, let's see, I talked about, SEL has a particular way we like to communicate in our style guide with our writing. And Nick, you were in that meeting. So I was talking about, okay, what's a good way to be able to train all of our folks who have a common understanding of this is the tone and the language we want to use at SEL. And I quickly transitioned to a meeting where we're talking about a particular product and how it's operating and the filtering characteristics that we're interested in for it. Then I moved into talked about somebody and personality profiles, right? We're interested in how I tick and how you tick, so we talked about that a little bit. Then we talked about some succession planning.
So that's the psychology thing. That was back to the first question.
You know what? And that's not my strong suit, right? It's like, why can't everybody be like me? It'd be so much easier.
That's terrifying.
You do not want a bunch of me's, right? I'm glad we're so diversified. I just need to understand how all you work, right? So it makes it more convenient. Then we did a little bit of succession planning activities. It's like, what are the attributes or the characteristics for the next person to be a VP of a different part of our organization, and what are the attributes we're looking for? And then, at whatever time it was, 2:30, I came down here and, hey, let's do a podcast, right? Yeah. So it's my days these days are very, very varied, right? Going from technical stuff to, let's call it, the touchy-feely stuff to, some marketing activities and creating a podcast.
What's the most energizing thing that you do? Is there one thing that's just like,
it used to be the technical stuff, right?
Yeah,
it's like that is so much fun. I think these days what gives me a lot of joy, right, is meeting some young person, maybe in R&D, maybe in marketing, up in manufacturing, and have them just be delighted to share what they're doing and why it is so cool, right? They're getting a lot of mojo out of what they're doing, and just seeing them appreciate what they're doing and being able to share it with me, right? It's that is so gratifying. I wish I could do that every day.
All right, Dave, this has been a lot of fun. Thanks for being a great guest today, and really appreciate the time that you took answering questions from our listeners. Thank you.
Well, Nick, thanks for being the host. It's always fun to sit down and talk to you. We should just put microphones in my office when we have one-on-ones, because we can get into some really philosophical discussions, if you will. Nick and I think we're always aligned, but we can come about ideas from different perspectives.
Get there different ways.
Different ways, right? And it's fun. It really is. So I appreciate you taking some time today to talk to me, and hopefully we'll have you on next season. And leading into that, then, I'd like to thank all our listeners for submitting some great questions and for listening to Schweitzer Drive. I'm looking forward to exploring more interesting topics and talking with more great guests in Season 7.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.